Now let us see the distribution of n objects into R boxes. That is, we are given certain number of objects and we have to find out in how many ways we can distribute them into, say, some given number of R boxes. Now here there can be various possibilities or the restrictions given as shown here. That is, the first one is the objects are either distinct or identical. So by distinct we mean that we can distinguish between any two objects, so they are not the same. Whereas identical means any two objects are absolutely same as each other, that is, there is no way to distinguish between them. Similarly, we can also have the same criterion for boxes or the containers in which the objects are going to go. So the boxes can be distinct as well as identical. Additionally, we may have the condition that whether the empty boxes are allowed or not allowed. So under various combinations of these conditions, we will now see how to derive the formulae or techniques to compute the number of distributions of this particular type. So let's move on to the first type, that is, we have identical objects and distinct boxes, and with the condition that the empty boxes are not allowed. Now here we can use what is called as the principle of balls and walls. So here we have to visualize the given objects by drawing them in a row. So let's consider that we are given certain number of objects. So let's say number them as, say, 1, 2, 3 and so on up to, say, object number n, and we have to divide them into R boxes such that no box is empty. So that means each box contains at least one object in it. So now division or the distribution into boxes can be visualized as drawing of certain number of separators between the objects as shown here. So as if it will distribute the objects into the required number of boxes. So now to use this principle, we have to first of all think of how many possible locations are there to draw the separators. So as we can see, there are total n-1 places where we can draw the separators. Now if we want to distribute into R boxes, then definitely we must have R-1 number of separators. So therefore, out of the available number of n-1 positions, we have to select R-1 positions where we can actually draw the separators. So therefore, total number of ways of distributing is nothing but n-1 C R-1. So that is, out of n-1 separators, we have to choose any R-1 number of separators which will give us the required distribution.